Okay, we're gonna start live here. Just gotta make sure to mute this. Mute this site. And we're live. We're live. We're going live.
Okay. Hello, everybody.
And we're live.
Hello, everybody. We can start. So, Ski, are you ready to rock?
And roll, of course. So, hey everyone, hello. I see Rafał Brzoska, Terminator. I don't look like a Terminator right now, but positively, I have the same amount of energy. So, just as usual, different place. I think this is an ongoing theme right now to just give you some sunshine from Hawaii and a little bit of spirit of aloha. Rafa, what are you playing? Alex is here. Hey, Alex.
Hey, Alex. Hey, Rafał. Hey, Lars. We have 20 people now?
Yeah,
Hey,
Seba is
Vita.
here.
Hey, how are you?
Oh, it's awesome. It's awesome to see everyone. I was like, Rafa, just hit me up. Let's learn and play and have fun with you together. I love it. So everyone's still alive. I'm excited. Welcome, everyone. Welcome. And aloha, like they do in Hawaii, I guess. So hopefully you guys are excited as I am to start and learn from, as usual. We have great speakers. They're passionate, as you guys are. And they are the experts in their fields. And it's just fun to hang out. I think that's the most important thing, having fun with it, learn, and just have a good time while, hanging out in this channel. And yeah, so again, welcome and get excited because we have two speakers. It's Shai and Manfred then. You all know them. And, without chatting too much anymore, I'll give it off to Shai. I think, Shai, are you ready?
Yes.
All right, man. Welcome and start it off. Let's get the show on the road.
Okay. Wow, nice. I didn't bring. I have also a sound effect and stuff like that, and we'll see. We'll see how if we need to use them. Let me share my screen real quick, and let's see. Let's see. Yes, this one I believe. Cool, right? This one?
Yeah.
No. Yes? No. Yes. Okay.
Okay.
Right? Can you see my screen?
Yeah.
Awesome. Okay, cool. So this lecture is about isolated integrated versus isolated testing. I always mess up like the integrate. Okay, it doesn't. The order doesn't matter. The material does. So let's start. Let's see if everything is okay. If I can move it. No. Yes. Okay. Awesome. Okay. So first of all, my name is Shai Reznik, and this is a picture actually of my daughter. She was photographed with her favorite like kid show, but actually I wanted to be instead of her, so I photoshopped myself there because I really love them as well. So yeah, this is this is me. I have a website called HiRes.io, and recently we focused everything on testing. So we have testangular.com, and we're the best place in the entire universe to learn about Angular testing. Okay, and by the way, and like it happens to be that in these days we are running a free workshop. You can go to the workshop on hires.link/roadmap, and it ends next week. So if you sign up now, you will get all the lessons and stuff while it's online. So make sure you do that. And I will share more details about it later. Cool. So let's start. Let me drink first. Okay. So why this talk? Why did I create this talk? I thought it will be beneficial to know the context. Okay, so integrate. So the reason I did it is because in recent years I read a lot about the fact that I read a lot blog posts, a lot of blog posts, and a lot of and so lectures that says that integration tester is everything you'll ever need, and we don't need isolation, and mocks are terrible, and you should avoid them at all cost, and these type of things. And actually, when I looked at it, I was like, really? Because I actually have a different experience with mocks. I actually love them. And this talk was originally, I wanted to call it Standing Up for Testing in Isolation, but I decided to expand its context and to learn more or to teach more about isolated versus integrated and stuff like that. Okay. So disclaimer, up front, I will tell you, you need both, okay? It's not just about isolated testing or just about integrated testing. You actually need both, but the amount matters, okay? So we need to figure out which test to write in which scenario, which can be, a bit confusing sometimes, okay? So I aim to provide in this talk the map of the different terms, and in the end I will share more stuff. So let's talk about the agenda. Okay, we'll talk about the terms, the pros and cons to isolated versus integrated for both types of tests, and also when to use what. Water. Cool. Okay. Well, sorry, I forgot to okay, I forgot to stop the notification, so we just ignore them. Okay, cool. So unit and integration, are these the right terms? I think they are overloaded terms because they actually mean different things. Because to ask whether you're testing, if you test your code, you use unit or integration, is like asking if you check your bank balance by using a hamster or communism. There are two different, non-related stuff. Okay, and let's see, because when I look at tests, when I first started learning about tests, these were the terms that got me confused, and I learned through the years about more dimensions to test or to testing and more aspects. So I decided to teach about testing and divide it into three aspects or dimensions. Okay, so let's show them. So the first one is scope, okay, or how many actions am I testing at once? Is it like one action, like method call or click of a button, or several? And the second one is boundaries, where to draw the line, like how many things to actually test in one go, in one test. And thank you. Okay, I guess so, admit. Okay, so cool, another notification. Hello, Manfred.
Hello.
Stay away. Shut off your video. We don't want to
Okay.
see you now. You're, yeah, you're ruining the show. I love Manfred. Okay, and the third one is subject. What do I need to create? Like, is it a class? Is it like DOM? I need to compile a DOM. Do I need to just import the function? So this is the subject under test. Okay, and this is the third dimension. So when we talk about let's take unit, for example. Okay, if we talk about unit, what are we which dimension are we talking about? Actually, unit holds inside of it two dimensions. First of all, what do I need to create? Usually we refer to unit as the class or the function or something like that. So this is the subject dimension. And also how many actions at once. Usually when people talk about like testing a function, they test it like calling it once, so this like also refers to the scope or relates to the scope. And integration is all about the boundaries. Okay, so like where to draw the line. So you can see that these terms are not really, are in the same dimensions when we talk about tests. And that's why, and by the way, something about integration test, okay? Integration test, like the Growing Object-Oriented Software Guided by Test book, the Goose book, talks about the integration test as a test that your code works better, works in combination with code that you cannot change, the code that like some other team wrote or some other external library wrote. So this is like the integration test definition by this book. And that's why a better term, okay, because, usually integration, it's something general. People use it to describe this type of test, but also like testing your code with your code. So that's why a better or like more accurate definition is like maybe an integrated test. That's why it's integrated versus isolated. So just to differentiate the Goose definition from like the more general use case. And while, as you can see, integrated talks about the boundaries, and because this talk is more about the boundaries, okay, we're focused on that. We also unit is not relevant to this talk. That's why I will replace it with isolated, and this is the isolated versus integrated, right? So, by the way, if you want to learn more about like the dimension, the workshop that I mentioned before, I go more deep into the different dimensions. Sorry, microphone. So you can go there, and it's up for like this weekend, as I said before. Okay. What? Okay, sorry, I don't have time for that. Okay. So terms, definitions. Let's talk about like what is integrated versus isolated, like the terms themselves. Okay, so integrated, we said we're testing multiple parts together. Okay, and isolated, we focus on only one part. It can be a class, it can be a function, but usually in Angular, we focus on classes, right? A component or a service or something like that. And we make sure when we write isolated tests, we fake all of the dependencies that we inject into this class. So that way we can focus on one thing. This is an isolated test. And now let's talk about the benefits. So let's talk about the benefits of integrated tests. So the first benefit is connectivity. We can actually test that the different parts works good together, and because we test the connectivity points between them, that actually the method that we call the other dependency actually, it doesn't break and stuff like that. So this is the connectivity. The second thing is configuration. So imagine like you forgot to import like an ng module, or you change the base URL of your HTTP calls. This you won't catch in you will catch in an integrated test most of the time. Okay, so these are the benefits that I see to integrated tests. But now let's talk about the issues. And the issues are usually issues that you won't see in like blog posts or talks and stuff like that when they praise integrated tests. But I wanted to stand up for isolation tests and to show you all the issues. And later I will talk about the issues of isolated tests as well. Okay, so sorry about that. So now let's talk about the issues. Okay, so the first issue is unclear boundaries. As we said, we test multiple parts together. Hey, Dariush. Hello. We test multiple parts together, and it's unclear where the boundary is, where we draw the boundaries. So let's say we have a component and service, and which depends on another service, which depends on the server. Where you draw the line when you say to someone else, okay, I'm gonna write an integrated test. Should I like mock everything from the service and beyond, or just the server, or not mock, not fake anything, and this will be like an end-to-end test. Okay, where to draw the line. So and usually when you talk about real applications, we don't have like this simple 3 classes app. We usually have more dependencies, which have more dependencies, and the cross dependencies, and usually it's more like this, and this is like a small app compared to like a real app. But for the sake of this talk, we'll focus on like this scenario. Okay, so you have unclear boundaries. What do I test here? Do I test this combination or this combination, or this is like a problem. Okay, what David, what okay, I will deal with that later. Sorry. Cool. So this is the first problem. The second problem is it takes longer to run, right? Because usually it depends on the test. If you have a server, you need to load the server. If it's with a browser, you need to load the browser, and also you have much more code to run, so it takes longer, especially if you test everything. Also, you have longer test setup. You need to write more setup code for your test, because usually we don't deal only with, when in integrated tests, when you test like a component, for example, it has other subcomponents and they have services too. And, you need to now, maybe even if you fake those services, you need to set it up, in your like before each or before the actual test run, before you run the action. This leads to a much like a bigger test. Mute here. Okay, cool. So this is this is another problem. Okay, and also it breaks more often. Okay, because you now have more stuff that can fail and can break your test, which leads to another problem, which is the if you have one the multi coverage problem. I see notification everywhere, so I lose my focus. Sorry. So the multi coverage problem. What is the multi coverage problem? This is the problem when you have an integrated test, or multiple tests that both rely on the same dependency, and this dependency like has an error or a bug. Now both tests or multiple tests are failing, and it's harder to know the root cause, and it takes more time to debug. Okay. What? I didn't forget. Sorry. Okay, so this is the multi-coverage problem. Another problem or issue is it's harder to trace down bugs. So if these tests fail, which one of these dependencies caused it? Okay, it will take us more time to figure this out. Also, it's harder to cover edge cases, meaning you have multiple paths that your app can go through, right? When you test it. So you need to set up something. So what do you set up? Do you set up all the possible use cases? If this has an error, or what if, it goes to the else, clause, and what if this returns an error? You have all these like multiple code paths that your test can go through, and it's harder to cover those, because it exponentially grows your testing code if you want to actually cover all these test cases. And yeah, so, and as we said, usually we're dealing with more like much bigger apps than that. So, and that causes us to so usually we focus in integrated tests on the happy path. Okay, what like makes the component to render or to show the list of items and stuff like that, and we usually ignore all the possible use cases that could cause this list not to render. Okay, and this gives us a false sense of coverage. Okay, to people who say, okay, only write integrated tests, it will give you like the confidence that you need to know. And they are also promoting only happy path tests. You don't have really don't have true confidence, because you're not covering probably all the possible combinations. So it's not that that integrated tests give you actually the coverage that you need. So this is one myth that I want to expose. Okay, another issue is looser code design. So when I write a test for this like structure of dependencies, I can actually have like not 5 services. I can actually have like two large services instead, and the test will still pass. So nothing really puts pressure on my code design to, separate things into smaller parts with single responsibilities and such. And that leads to giant files. This, ladies and gentlemen, is called job security. Okay, this is a real file screenshot from a project that I did consulting to, and yeah, so, and I need to fix stuff there. So yeah, this is what happens when you either don't have tests or you have only integrated tests. And this leads to a more messy code, as you can see. Okay, cool. So this is looser code design. Nobody, the test doesn't like shout at you that you need to break your subject under test into more units. It's actually on mute. Okay, so nobody actually shows you the signals. Cool. Now let's talk about isolated test benefits as a comparison. So we'll go through it quickly because they are the opposite of the limitation, but we'll just to show it in a different way. What the? Sorry. Okay, isolated test benefits. Cool. So the first benefit, sorry, I got distracted, is clear boundaries. Okay, now we know that we fake everything, so we are focusing only on one subject under test, and it's easy to see. Also, it's faster, much faster. It runs really, really quick. Less setup code because, again, we only have one thing to set up. No multi-coverage problem. If one thing fail, the test fail. If another thing fail, its test will fail. So we don't have the multi-coverage problem. Also, it's easier to trace bugs, okay, because you can see clearly where the bug is. And it's easier to cover edge cases because we only deal with the dependencies that the first level dependencies of our subject under test. So if we want to simulate what happens if an error comes back, we can do it easily. Okay. You're doing great. Love you. What? We're in a talk. It's not like again. Sorry, why for you send me and okay, so not now. Okay, we'll talk about it later. Okay, cool. Thanks. And also, I'm married. Okay, sorry about the discretion. I should put a reminder to close the notification next time. Okay. Cool. Easier to cover edge cases. Okay, we saw how it's easier, and also documentation. Okay, so we have a sort of a live documentation for our units under test. When we write isolated tests, it's much clearer to see what this particular subject under test is doing. Okay. And also it leads to better code design because now if our service grows bigger or subject grows bigger, now the test will scream at us, hey, we have too much setup code, you have too much things, you need to separate it, and it will lead you to break things into smaller because it will be painful to write these tests. And also it leads to more like files and methods of like that has single responsibility, which is great, and it's much more clean. Now let's talk about its issues. So again, it's harder to catch config bugs. Okay, so you won't catch like if you change a base URL or we didn't import a module or and stuff like that. So it's not isolated, like you won't catch it with an isolated test. And also you have to write more tests, right, for each thing. But I argue that you don't really, if you needed to write the same test or to cover the same path in an integrated test, you would have to write much more like tests in order to cover that. So you actually write less tests and get more coverage of the different path. But some see it as a problem as well. So just want to argue against that. And you cannot catch collaboration bugs. So for example, if you fake everything, you won't catch it. You won't if you will change the real service behind like the fake one that you like the mock, you probably won't catch it. So if this changes and you won't catch it, and you could have bug in your collaboration. So if you call something with like a configuration object and it expects true instead of false, you won't see it in an isolated way. There is a way to cover that without writing an integrated test, which is like covered with collaboration and contract test, which I call symmetric testing. And I teach about that as well. But this is also hard to do for some use cases manually. So I'm working on an open source library behind the scenes that might do it automatically, but we'll see about that in the future. Okay, sorry. Cool. So which one to choose? When to use what? What I promised you in the agenda. Okay, let's talk about that. So for small apps, I say just write integrated. Just integrated tests are fine because it's small. You don't have a lot of code paths to cover, so you could get all the benefits you need. So it's good for like microservices or maybe front ends, although you will need the connectivity between those small apps. You need to cover them as well. So we will have this problem to tackle. But for small apps, I think that just integrated is fine. But for medium to large app, I say, use integrated tests just for like a smoke test, which test all of your app together, like an end-to-end, and covers all the critical points in your app. And also for special use cases when you need an integrated, like to integrate multiple parts, but those should be rare. And for the rest, use isolated tests and symmetric testing and stuff like that. So yeah, this is like I said, I cover the other boundaries, the other dimensions more in more depth in this free workshop. So join in this link, and that's it for me. Thank you very much. I hope I wasn't on mute this whole time, but yeah, that's it. So I will.
Okay, thank you so much, Shai.
Unfortunately,
Unfortunately, was muted all the time.
Yeah. And applause. Yeah.
Can you hear me, Shai?
Oh, I cannot hear you. You've been talking. Okay, now I can hear you.
Okay. Yeah, because you was muted all the time.
Oh.
Can we repeat it?
Damn it. God damn it.
No.
I knew it.
Man, thank you so much for this great presentation.
No problem.
A lot of valuable stuff. I totally agree. We should do the isolated test for everything. So yeah.
Thank you. Appreciate it. And,
thank you so much, man.
I will see you in the chat. Now I will do the stop video and I will disappear. Ready? 1, 2, 3.
Wow, thank you. Okay, Manfred. Where is Manfred?
Here I am. Hi.
Hi, hello. How are you?
Yeah, fine, thanks.
Okay, so our next speaker is the greatest Angular architect, Manfred Steyer. Yeah!
So thanks for having me. It's really a pleasure to speak here at this event. And I brought some stuff with me. Perhaps I can even switch to it. Yeah, here we go. So this will be about module federation, which is quite a new topic. And if you ask me, it will lead to a micro-frontend revolution. But first of all, let me get started with a picture. Who remembers this woman? If you just think about your past, perhaps you've seen her before. I give you a little hint. Yeah, she was from Knight Rider. She was Bonnie, and she was the engineer in the Knight Rider team. And she really inspired me when I was a child because she fixed all those things. She was the electrical engineer and the computer scientist on this team. And I think she was one reason why I told my parents that they have to buy me a computer. I told them, hey, you know, it might be beneficial for school, which was not really wrong, but also not really the truth, something in between. But one funny things come in mind when thinking back to Bonnie. She was somehow a one man or a one woman show. And this is normally not the case. Normally, when it comes to computer science, when it comes to software engineering, we don't have one man or one woman shows anymore. Because software engineering is a team sport, isn't it? We need to coordinate a lot of people with different backgrounds and different skills. And when we speak about huge applications, we don't have just one team, we have a bunch of teams. And so we need to coordinate all of them. While coordinating the people of one team is hard enough, coordinating several teams can really be a challenge. And there is one solution for this. This solution is quite old. It tells us we shall not write a monolith, which is a big software application capable of everything. Cooking a coffee and searching a shirt for me and booking some flights like this flight system here. Instead of this, the idea is to write several tiny systems. For instance, a booking service, a check-in service, a luggage service, or a boarding service. In the backend, we are calling those services microservices for some years. The idea is quite old, but the term is new. And in the last years, this term became quite popular. The idea is also that all those services are isolated from each other, which means that one service does not know much about the other ones. If one service does not know much about other ones, we can develop the service in isolation. We can enhance it, we can add new features without having the fear to break something over there within another service. That's why the lesser they know about each other, the better it is. When we take this idea of subdomains which make up microservices and put this idea into the world of frontends, we will end up with microfrontends. The idea is basically the same. We don't write a big front end. Instead of this, we write several tiny front ends, which can be written in isolation, which needs to know much about each other, which can be deployed also individually. And now, of course, the big question is how to implement such micro front ends. And there are several answers. There are several approaches for implementing micro front ends. However, so far, none of those approaches was really a great one. You needed to use several tracks, toe manipulation, iframes, things like this. So it was not that great. But the good message is, with Webpack 5, we will get a feature called Module Federation. And Module Federation solves all, or at least most of those issues. It is the first time we get an out-of-the-box solution allowing us to write sound micro frontends. And this is exactly what this talk is about. In this talk, I will tell you first of all what the consequences of micro frontends are. Because micro frontends are not a silver bullet. Micro frontends have a lot of downsides, and before deciding for or against micro frontends, you should know their advantages as well as their disadvantages. Then I will show you how to use module federation, and at the end I will present you a possible roadmap. But First of all, let me introduce myself. I am Manfred. I'm a trainer and consultant for Angular. I'm helping a lot of companies around the globe with remote Angular consultancy and remote Angular workshops. My current workshop is this one here, which is about architectures for Angular for enterprise and industrial applications. And besides this, I'm also quite connected to the Angular community. I'm doing a lot of stuff in the German-speaking area of Europe, but I'm also happy if I can visit other countries like Poland, like Warsaw, and I was several times there. Okay, so let's get started with the first chapter of this presentation. Let's get started with the consequences of microfrontends. As mentioned before, microfrontends allow you to subdivide a big application into tinier parts. And this in turn allows you for autonomous teams. That means we can have one team for each and every subdomain, one team for each and every microfrontend. And they can work individually on their parts, individually without influencing each other. They can even publish or deploy their parts when they are done. So, as mentioned, one advantage is you get a separate development, so you don't influence each other, and you can even separate deploy your stuff. That means when you are done, you just deploy it. You don't need to wait for other teams. Perhaps you know this situation. You are done, you have created some business value for your customers, but your customers will not see it because you have to sync with other teams. You have to sync up, you have to wait for other teams, and only then you can deploy everything together. This is not the case when it comes to micro frontends, to microservices. Also, each and every team can do their own architectural decisions. And architecture is not a one-size-fits-all solution. Different subsystems might need different architectures, and so you can choose what's best for your current subsystem. The same holds true for technology. Each team can do its own technology decisions. But here I would take care, because it does not make sense to create a framework suite, to mix Angular with React and Vue and so on. It's possible, but I would not do this, at least not in short term. In short term, it would be beneficial if everyone used the same framework. But in long term, this is needed, because a business application needs to be maintained for, let's say, 10, 15, or even 20 years. And in the course of 20 years, a lot of things happen. So it would really be beneficial if you was able of exchanging your technology by another one for the next subsystem you write in, let's say, 7 years. If you ask me, for this reason, micro frontends is a really honest architectural style. It's really honest because it tells you from the beginning that there will be the day when your technology is obsolete, when you need to exchange your technology for another one because yours is deprecated or will not be maintained anymore. But as mentioned, in the short term, please keep with one framework. Saying this, I think this all clearly shows that micro frontends are first and foremost about scaling teams. It's not about fancy architectures. It's not about mixing frameworks. It's really first and foremost about scaling teams. And a good friend of mine told me that teams is plural, which means more than one. And that means in turn, if you only have one team dealing with your front end, don't even consider micro frontends. Perhaps there might be some advantages for your case, but in general, you only reach the sweet spot of this architectural style if you have several teams, if you need to coordinate those teams, if they work on the same overall software system. And of course, there are challenges. That's why you need to be cautious. So, for instance, one challenge is UI composition, which means you need to present your 50 micro frontends as a common thing to the user. We as developers like the idea of having 50 less complex subsystems instead of one very difficult and complex one. But the user does not like it. The user is not interested into starting 50 applications each and every morning. So somehow we need to present everything as a common product to them. Also, we need to take care about UI consistency. Somehow it would be nice if your overall system would have a common look and feel. In some situations, this is more important. In other situations, it's less important. When you think about a shopping system, consistency is very important because consistency provides some kind of trust. On the other side, if you think about an ERP system, SAP for instance, it does not matter that much if the data grid in the accounting part looks a bit different than the data grid in the payroll part. It is not fun, it is not perfect, but I think when it comes to an ERP system, you have bigger challenges and bigger issues, like writing the right invoices, like paying the right amount of money to employees. Most of the time, they are not happy if they get too less money. Also, we need to take care about bundle sizes. We don't want to end up having Angular 5 times in our browser because we have loaded 5 micro frontends. We just want to load Angular for one time for our overall system. And also, we need to take care about version conflict. Using Angular 5 side by side with Angular 9 will lead to conflicts. It might work in some circumstances, but in other circumstances, it will lead to ugly conflict. So better prevent this. And there are some additional challenges, but I think for the time being, those 4 challenges are enough. That really shows that it is not a silver bullet. It really shows you need to think twice before you decide for micro frontends. If you can deal with those challenges, if you reach the sweet spot because you have several teams, then it might be a really beautiful solution. If this is not the case, then perhaps the challenges overweight the advantages. The good message is module federation, which comes with Webpack 5, solves some of those issues. For instance, they give you a way to deal with UI composition. You can load a separately compiled micro frontend into your shell. They deal with bundle sizes. You can share dependencies. You can share Angular core, Angular common, Angular router amongst your micro frontends. And they allow you somehow to deal with version conflicts. Perhaps it is not the ideal solution because it seems like there is not something like an ideal solution when it comes to preventing version conflicts. But there are some ways you can try out. And this leads to the second part of this presentation, which is about module federation. I am always saying module federation is a bit like the 1980s. You have to experience them to grasp them. And that's why I'm starting with a demonstration. So if we look into my browser, here I have a shell application, and this shell application is capable of loading separately compiled micro frontends. Everything within this dashed line here is a micro frontend, which has been separately compiled, separately published. It even runs in standalone mode, as you see here. And my shell is just loading the newest version of it or a configured version on demand. So if you don't trust me, let me reload the page and let's have a look into the network tab. I'm clicking here to flights, and here we see my bundle is loaded, the bundle with the beautiful name 798. And as you see here, it only has 3 keys, which is nothing. This really shows that module federation allows me to share libraries like Angular itself between all the frontends. Angular is obviously not loaded another time here. It is just reused. Angular was loaded once into the shell, and now it's reused by this Microfrontend, even though it was compiled separately. Perhaps you are saying now, come on, Manfred, that's nothing special. This is just lazy loading, isn't it? Well, it is a bit more than lazy loading, because if you look here, you see localhost 5000. And if you look there, you see, yeah, right, localhost 3000. So it really comes from different origins. And that was not easy to accomplish with former versions of Webpack. So the big question that is answered by module federation is this here: how to load separately compiled code into your shell. And perhaps you're saying now, well, that's not that difficult because we have dynamic imports. And even before dynamic imports, we had this require statement or this require function. And so it is not that difficult to point to another origin. And now I'm saying, no, that's not the truth, because Webpack does not allow for this. Webpack does not allow for pointing to other origins with an import or a require statement. And because of this, also the Angular CLI does not allow, because the Angular CLI is using Webpack underneath. The thing is that Webpack assumes that everything is there at compile time. Webpack needs to have all the code available at compile time. Everything is compiled together, some optimizations are performed, and then your big application chunk is subdivided into smaller chunks for the sake of lazy loading. That's the reason why this was not really possible before. But module federation is changing this. Module federation introduces a role called the shell or the host, and another role called the remote. In my case, the shell application is the host, and my microfrontend is the remote that has been separately compiled, the remote that is loaded on demand into your shell. To make a shell out of an application, we just need to add some configuration data to the Webpack configuration file. Configuration data like this here, which maps an URL. In this case, I'm mapping the URL mfe1 to mfe1. So it's an alias, or to say the least, a non-alias, because I'm mapping it to the same name. But basically, that means that each and every URL starting with mfe1, which by the way stands for Microfrontend 1, I know, very creative. Each and every URL starting with mfe1 points to something which comes from another origin, points to something that has been separately compiled, and which is also called mfe1 over there. Also, the Microfrontend will get some configuration data like this exposes section. Using exposes, you can expose specific files, specific building blocks to your shell. In this case, I'm saying, hey, the whole file, my component, is exposed as the component. And then something beautiful happens. I guarantee you, now something really beautiful happens. You can do something like this. You can export mfe1/component. And so, because mfe1 is mapped to an external implementation, it is pointing over there to our microfrontend. And over there, this component here is loaded, this component that has been exposed. And so loading something that was separately compiled is really a piece of cake. Adding those lines of configuration settings is not that difficult. Perhaps you are wondering how the shell knows the URL of the microfrontend. Well, for the time being, you get the remote entry point when compiling the microfrontend. Webpack takes care about it. It is just a tiny file, just a tiny amount of bytes. And this remote entry point needs to be loaded into your shell. You can create a hard-coded script reference. You can create the script reference with some lines of DOM magic, with DOM manipulation. Or meanwhile, you can even call a configuration function of Webpack, and this configuration function then takes the URL of this or that microfrontend, which means you necessarily don't need the remote entry point anymore. But the most simple way to go, the simplest way to go, is just to load the remote entry point from over there. This tells Webpack where the microfrontend is located. So another question you might come up with is, what's about sharing libraries? And the answer is, well, this is also quite simple. You can define a set of shared libraries on both sides. And if these libraries match, then the microfrontend, the remote, will just reuse this library which has been loaded by the shell. If the shell did not load this library, the microfrontend just loads its own library version. So this is quite smart. If it's there, it is reused. If it is not there, it is just loaded on demand. Of course, the most difficult aspect of this is version conflicts. You might end up with version conflicts. Perhaps the shell is using Angular 7, your microfrontend is using Angular 9, and if you try to use both together, all hell breaks loose. That means you need some solutions for this, and saying this, Module Federation gives you two solutions. First of all, you could configure Module Federation to reuse the library anyway. You can say, oh, it does not matter. I'm a lucky person, so I guess it will work. Normally, I needed Angular 9, but I'm okay with Angular 7 because what shall go wrong? Perhaps this is also the ostrich strategy, you know, the ostrich, this bird which is sticking his or her head into the sand when there is some danger, just waiting until the danger passed by. Another approach is that the microfrontend could load its own version of Angular, which means the shell would go with Angular 7 and the microfrontend would go with Angular 9. In the case of Angular, both might be bad. Both solutions might be bad. In the case of a tiny library like RxJS, it might be okay to go with version A or B. But when it comes to your leading framework, both solutions seem to be a bad choice. And if you ask me, in these cases, you need to prevent such a configuration conflict, such a version conflict by yourself, by introducing conventions, by introducing contracts, or by using a monorepository, which is forcing you to just use one version of Angular, of NGRX, of Material, and so on and so forth. Of course, integration testing can help because it shows that everything still works after deploying a new application part, a new microfrontend. Okay, so much for the theory. Let's have a look into my example. Let's find out how my example has been configured. For this, I'm just looking into my Webpack config.js. And here you see it is an ordinary Webpack configuration, and it just has this additional configuration section pointing to the Module Federation plugin. And it points to a remote which is called MFE1, Microfrontend 1. It's also called MFE1 over there in this separately compiled bundle. I'm also telling the shell that I want to share those libraries, Angular Core, Angular Common, and the Angular router. This is everything you need to get started with your shell and module federation. Of course, this Webpack configuration is quite huge, and normally we don't write a Webpack configuration by hand anymore. In the world of Angular, we have the Angular CLI, which creates this Webpack configuration. So everything we need to do is to find a way to squeeze this little configuration fragment into the already existing Webpack configuration provided by the CLI. But as you will see in some minutes, I have a solution for this. This is the shell, just pointing to another microfrontend and sharing some libraries. When we look into the configuration of the microfrontend, we have more or less the same. We also have the module federation plugin. It gives the microfrontend a name, namely MFE1. Here we have the name of the generated remote entry point. And here we are exposing stuff like an Angular component or an Angular module. That means that the shell can load those building blocks dynamically at runtime. And of course, also I have this shared stuff here. I have this shared array which defines all the libraries I want to share with the shell. If we now look into our approots file, the approots file of the shell, we see something that's also quite beautiful. We are using here the router in a proper way. We are using the router as always together with lazy loading. That means from Angular perspective, we are only doing lazy loading. But as you might see here, I'm pointing to a module which is mapped to a microfrontend. That means when Webpack sees this at runtime, it does not search the current bundle for this module, it searches the bundle over there for this module. And of course, first of all, this bundle over there, this microfrontend is loaded. But from Angular's perspective, this is just lazy loading. That means we don't need an extra solution for loading our microfrontend, which is kind of nice if you ask me. Also, we have to tell the shell where to find the microfrontend, and for this we need to load the remote entry point from over there. Here I'm doing this with a static script reference. I could also create a dynamic script reference, or you can meanwhile do this by calling some functions of Webpack. The pseudocode looks like this: do it Webpack. I think the real function name has a different name, and here I can then provide all the URLs of my mapped path. That's also possible, and that's even necessary if you have a dynamic amount of microfrontends, or let's say a dynamic amount of plugins. Okay, that's all. So it's pretty much a straightforward thing. And that's why I'm really looking forward to module federation, because as mentioned, currently, you need to deal with a lot of workarounds to accomplish the same. Perhaps you also like this idea, and so the next question is, when can we have it? And well, there is not an official roadmap, but if I'm looking into my glass sphere, I can tell you several things. First of all, Webpack 5 is currently beta, which means we cannot use it for production, and it is not used by the Angular CLI. The Angular CLI is always using the latest stable version of Webpack, which is obviously currently version 4. The example shown here, by the way, is a proof of concept which is using a custom Webpack config. You've seen it, but it is also using a patched version of the CLI. So don't do this at home, don't do this in production. It is good enough for this proof of concept, but I guess you don't want to work on an enterprise scale application with a homebrew patched version of the CLI. You deserve better and also your teammates deserve better. Also, the CLI will not use Webpack 5 before version 11, which is due in fall, I guess in November. Very often November was the month where the fall version of Angular came out. I can tell this because Angular 10 is due in the next weeks, and as Webpack 4 is the current stable version, it will for sure use Webpack 4. But hopefully, if Webpack 5 arrives in time, and if the Angular team manages to use it for CLI 11, we can get it in fall. For me, it looks quite good that this will be possible. Also, you need to find a way to squeeze this federation configuration into the CLI's Webpack config. But for this, we have solutions. Perhaps you know the CLI is pretty enhanceable. We can, for instance, write custom builders to define how ng build works. Those builders are exchangeable. The main builder is using Webpack. The builder for libraries is using ng packager. And so it would be possible to switch this default builder by another builder which is capable of enhancing the Webpack configuration. If you need something like this, you can even today use nginx build plus, which is an open source builder, and it allows to squeeze an existing Webpack configuration into another one. It is just performing a merge, which is what we need here, merging the module config with the Webpack config. That means we just need some patience. We need to wait until fall. Let's do some hibernating until then, and then we will have this beautiful future. Okay, cool. So if you like this talk, I have updated my ebook with this topic. I've updated it with a chapter about module federation, and there is another chapter with alternatives to module federation. So if you like this, you can check out my ebook. And if you didn't like my talk, check out my ebook anyway. Perhaps I'm writing better than I'm speaking. Who knows? Of course, I'm writing without accent, so perhaps you like it even more. Okay, let me come to a conclusion. What did we see today? We've seen that the main purpose of microfrontends is scaling teams. It is really a dry topic like this. It is not about fancy technologies or mixing technologies. No, it's about scaling teams, and that means you need to have more than one team to reach the sweet spot. Also, it's about decoupling, which means that one part of the application, one micro frontend, should not be coupled to the other ones, because when changing something here, you don't want to break something there. Module federation allows you to import from other applications from other origins. So this seems to be the first sound official solution for creating micro frontends. Also, module federation allows you to share libraries, but please take care of version conflicts, because if you ask me, currently there is not a sound solution for preventing all the version conflicts. You have to take care about this by yourself, by leveraging some conventions or by using a mono repo, by using a mono repo. And there is a last thing I want you to remember. If you forget everything, please don't forget about this woman, about Bonnie, and please try to be a bit like Bonnie, because Bonnie is always thinking first. In opposite to her colleague, this Mitch from the beach, I don't remember his name, he was always hitting first and thinking then, but Bonnie is always thinking first. And if you try to be like Bonnie, first of all, you will evaluate if you need micro frontends. And if you say, no, I don't need them, and go with a majestic monolith. You know, the micro-frontend people, also the microservice people, are claiming that a monolith is something that's bad. For them, monolith is a curse, a bad word. But honestly, it does not need to be something that's bad. If you take care about your monolith, if you make sure that not each and every part is accessing each and every other part, it can be something that's beautiful. It can be something that's majestic. That's why friends of monoliths coined this very term here. Saying this, if you want to build a majestic monolith, have a look into NX, because NX enhances the Angular CLI with some tools allowing you to create loosely coupled monoliths. And if you say, yes, I need all of this because I have several teams and they need to work in isolation, they need to do their own decisions, then consider module federation. In this case, if you ask me, module federation is a very attractive upcoming technology. So thanks for having me. I have already uploaded all my material to my blog. And if you want, follow me on Twitter so that we can keep in contact. Thanks and enjoy the rest of the evening.
Thank you so much, Manfred. Yeah, it was amazing, amazing, amazing presentation. Big
Pleasure.
One more time for Shai and for Manfred, but this is not the end. Today we have a special guest, Rafał Brzuska. He will present some very special Angular rock and roll stuff. So one more time, thank you, Manfred. Thank you, Shai. And Rafał, the stage is yours. Have fun.
Can you hear me?
Yeah, of course.
Okay, so I am so happy for the module federation and for the isolated test that I composed a song. No, it's a traditional Salesian song. I want to play for you for the nice weather behind the window, and let's play.
Oh yeah, rock and roll. Thank you so much, Rafał. And once again, thank you, everybody. It was great, another great meetup. And we see in 2 weeks. Thank you so much.